what you were able to think through. I know I kind of cut you short in some ways, especially down here, but it's because we didn't get to that example yesterday. And so I think it'd be helpful if we kind of talk through it together. Let's start with number 125. On which interval is the graph of f of x equals 2 over the square root of x minus 1 not continuous? What did you guys think? Not continuous. How come? It includes 1, and what's wrong with 1? Yeah, it's a number over 0. It's actually a vertical asymptote, but it is a discontinuity, but it's a number over 0 if you plug it in. Second one, for which constant c is the graph continuous? How can we make this continuous? What do we need to happen? Uh-oh. Okay, we need both approaches to agree, and we need the approach. What's that called? Starts with an L and ends with an limit. Okay, we need the limit to agree with what? I think someone might have said it, and I kind of didn't hear. The 3 conditions for continuous. We have a forever quiz on Monday. You have to have these cards memorized, especially quote the definition of continuous, state the entire intermediate value theorem. Definition of continuous. What's the first thing? F of c. So I need the point. So I need the point. I need f of 1 to equal the limit. Now, is this piecewise function one where... What am I doing right now? Okay. Is this piecewise function one where I have to come from either side? Or from both sides? Because this isn't a greater than, less than type 1. This is a not equal to, equal to. So for the limit, why did I just choose this part and didn't put a below or an above? Because where's the below going to be? Where's the above going to be? Where's 0.9999? Here. Where's 1.001? Here. Does that make sense? So all I need is him for the limit. And then f of 1, well, isn't that just c? So c is going to equal the limit as x goes to 1. Wait, why am I factoring more, cool kids? Why didn't I just plug in? It'd be 0 over 0, keep going. And so, now I can go ahead and plug in. What's 1 times 1 minus 2? That's negative 1. What does c equal? Dun, 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 dun. Who got it right? Ooh. 4, 5. Hey, well, on an AP, sometimes guessing will get it right. Always guessing won't get you the score that you want, but sometimes guessing is appropriate. On a test, if you have no clue and time is running short, what should you do? Guess. Maybe you'll be right. Okay, number 127. How do we make this whole thing continuous? Does he have any domain problems by himself? Nope. Does he have any domain problems by himself? Nope. Does he have any domain problems by himself? So where could there be problems? Not there, but where they meet. Good, at the separators, and there's only 2 of them. So we have to make everything match up at -1 and at 3. At -1 and at 3. So, do you guys see how the below and the at is the same thing? So I could go ahead and say f of -1, which is the same thing as the limit as x goes towards -1 from below of p of x is 2, right? Whether you plug in -1, there's no place to plug it in. So f of -1 is the same thing as the limit from below, which is 2. But what do I need that to equal? I need the below to equal the continuous. I need the one-sided limits to agree. So I need to not only come from below, but also from, okay. And so from above, I can go limit as x goes to -1 of p of x, which would be a times -1 plus b. How'd I do that? Plug it in, yeah. because the above is greater than, I plugged in -1. Now, is that enough to solve for a and b? No. But I can say that 2 needs to equal -a plus b. That's one equation. How am I going to get another equation? Because I need 2 equations with 2 variables. Do everything with the other separator. Good. So I can say f of 3 is equal to, which limit does f of 3 equal? From below or from above? What did you say, Ryan? Yeah, the positive or 3 from above, right? And that would be my -2. And what do I need that to match up with coming from below 3? Good. So limit as x goes to 3 from below. Why is it going to be different than this one? Why is it now 3a plus b? Yeah, good, because I have to plug in 3 to that piece. So now I have the equation -2 has to equal 3a plus b. All right, algebraic kids who went through Algebra 1 and Algebra 2 in pre-cal, how do I solve that little baby system? Cancel out the a or b and then solve? Yeah, so elimination? Okay, can we do it right here with the b's? Are you guys okay? Okay, let me change colors. If I can do a little like multiply everything by a negative, right? So that would be a +2 and a -3a and a -b. Haha! Those will cancel. 2 plus 2 is, and then I get -4a. You guys agree? So I can go ahead and say that a is equal to -1. And if a is equal to -1, is it okay if I go here? Then I can say 2 is equal to -1. So what does b equal? Yeah, subtract it, 1. Good. So a is equal to -1, b is equal to 1. How would you check it graphically? Well, I guess you could remember Booleans from the pre-cal graphing calculator handbook and how you can actually put this in your calculator, or you could graph him and then graph him with -x plus 1 and then graph him and see if they match up at -1 and see if they intersect or match up at 3. You could do that. Just graph y1, y2, y3, and they will match up at -1. They'll hit, and they will hit at 3. Those two, and then those two. How were they asking me to do this one? How do you take the limit towards 0? He's not a separator. Which piece? 1, 2, or 3? Ah, why 2? 0 is in between -1 and 3, so all you have to do is plug it in, -1 is a, times x plus b. What would the final limit be? Plug it in, -1 times 0 plus b just equals 1. Okay, that brings us up to number 128. We're going to go ahead and not grade number 128 right now. Well, how many of you guys actually got to 128, like even looking at them? Good, good. Some of you didn't, though. So let's go ahead and save him for right now, and we'll come back to him, okay? We're going to go ahead and figure out life. Let's go to section 1.5 notes. Let's go to section 1.5 notes. Have we graded 1.4 homework? No. So here's what I'm going to do at the very end of class today. No, I'm not going to do that. If we didn't have a homework due tomorrow, I would have you guys grade it with a video. Homework due tomorrow. So let's just cover 1.5. Let's make sure we're good on it, and then we'll grade 1.4 and 1.5 tomorrow. Sound good on a non-chapel day? Okay. So tomorrow I'll start off with your color pens and your homework spirals out and ready to go, and we'll bust it out. So 1.5. Number over 0. Oh my goodness, haven't we seen this one before, guys? So maybe this section is kind of review from the summer review or the summer packet. And for honors kids, review from last year. And for regular kids, kind of review from last year. We just didn't call it limits. What should you be thinking as you see number over 0? Thank you. Infinity and beyond, right? I just need something that'll stick in your brains, because in April, when the AP is a-coming, you're not going to remember plus or minus infinity question mark. Most of you will not remember plus or minus infinity question mark. Infinity and beyond. If you guys look at the backboard, which probably most of you haven't, but if you look, limits at infinity, we're dealing with horizontal asymptotes, so going to infinity and going to infinity, degree tests, and then vertical asymptotes, number over infinity, infinity and beyond. I want you guys, once you get down to the example, to see if you could kind of show me a sketch as to what you think that function looks like. There we go. Infinity and beyond. Oh, we should see. Thanks, Ellie. Hopefully, get your fingers on this. Who's thought of something as far as how to sketch that graph down below? Something that we should think of all together, if we're trying to graphically think about it. Look on the backboard, pre-cal today. No, honors pre-cal today. Section 1.6, first semester, last year, library of parent functions. Basic graphs and functions. Why am I bringing that up right now? Who should you be thinking of? 1 over x. Ryan, what do you got?
All right, so the vertical asymptote is at 2.
Good.
Obviously, 2x is 0.
Hopefully.
And then to figure out how the graph behaves, you plug in slightly above 2 and see what the sign is, and then...
You could do that. So 2.1-ish. What would that be, guys? Positive or negative? Okay, what about 2.01? What about 2.001? All these are positive? Oh, it's a vertical asymptote. What's going on as you get closer and closer? Hey, the basic graph does that too, right? What if you plug in 1.9, 1.99, 1.999? They're negative. But doesn't the basic graph do that too? How did I know that it needed to skim the line or the x-axis or the line y equals 0 also? How did I know that? There's a vertical asymptote at 2, right? Because Ryan already mentioned, obviously, but what he meant by that was the denominator can't be 0. Or you could also think it was the basic graph, which has an asymptote at 0 shifted right too, if that helps. But how did I know the horizontal asymptote? Degree test. Horizontal asymptote is the exact same thing as the limit as x goes to positive infinity of a function says who's stronger? Thinking about the magnitude or the powers of the variables. The top, there is no variable, so it's a 0 degree. And the bottom, well, the bottom wins. And what always happens if the bottom, the divider, wins? He's dividing like crazy. And what happens if you divide a pizza into tenths and then hundredths and then thousands and then millionths? What's happening to your piece? Exactly, which is why the limit is 0, which is why the horizontal asymptote is 0. I'll review stuff from the summer packet. But hold on, what were they actually asking me to do? Analyze the behavior near the vertical asymptote. Last year in pre-cal, we had to write sentences like coming from below and coming from above. Now we get to be all snazzy and say, psh, from below is easy. Limit as x goes to 2 from below. What would the answer to that be? Negative infinity, good. But wait, how did Ryan do it in his head without even having the graph yet, even though he was getting to the graph? What'd he plug in? No, not 2. I mean, 2 showed vertical asymptote, less than 2, 1.9, and what did he do? Checked the sign. Good. Then limit as x goes to 2 from above. What did Ryan do? Plug in something a little bit bigger than 2, and what was the sign? But doesn't the graph show the same thing? So depending on your brain, one will be easier sometimes than the other. But the functions do get harder than this. This is like a basic graph. Kind of hard transformed basic graph, but a basic graph nonetheless. Let me dual page just for a second for any of you guys still catching up. But what's this page going to talk about? How? Ooh, you guys can't see the question. How can we determine behavior near the vertical asymptote without a graph? Well, to be honest, I don't think you need this table because we just did all the work because you guys were awesome and remembered. So let me just use the table. That didn't work. How can we determine behavior near the vertical asymptote without a graph? A function will either increase without bound or decrease without bound when approaching its vertical asymptote. So let's say we're approaching some little guy A. Let's say at A is number over 0, which technically doesn't exist, but we know that's going to be plus or minus infinity with a question mark. So what we need to do as we think about coming from below or coming from above, as we approach, we're going to be checking the sign of, we know it's going to be infinity. If it's a vertical asymptote number over 0, it's always going to be infinity. But which one? We got to check the sign. And how do we check the sign? Just like Ryan did over here. He plugged in 2.1. And he didn't care about what the decimal answer was. He just cared positive or negative. And then we followed up and plugged in 1.9, and we didn't care about the decimal, what it would actually be. Because of the number over 0, we knew it wasn't infinity. We just had to figure out positive or negative based on plugging. So check the sign by plugging in. Why am I saying kinda? Because you don't need to simplify. It doesn't matter what the actual number is, right? All we care about is the what? Sign. It's getting exciting outside. All we care about is the sign. So the way I put it somewhere else, technically that would be the algebraically. Is we could pretend plug in. That's why I said kinda up above.